Supermesh Analysis. Suppose any of the branch in the network has a current source as shown in this network, then it is slightly difficult to apply mesh analysis straightforward because first we should assume an unknown voltage across the current source, writing mesh equations as before, and then relate the source current to the assigned mesh currents. This is generally difficult approach. One way to overcome this difficulty is by applying supermesh technique, in which we choose the kind of supermesh. A supermesh is constituted by two adjacent loops that have a common current source. Example, in this circuit, we have three loops, that is I1, I2 and I3. So we need to get three equations. Since we have a current source in loop 2, we will consider this as a super loop. Then we'll write the equations. Now the loop 1 and 2 is clubbed, so V equals to R1 belongs to I1, so R1 I1, and this is opened, so now our loop is like this, plus R3 of, here the current I2 is flowing and the current of I3 is flowing in opposite direction, so I2 minus I3. Now if you rearrange this, R1 I1 plus R3 I2 minus R3 I3 is equals to V. This is our equation number 1. This is for a super loop. For the third loop, we'll write R3 of I3 minus I2, this is in opposite directions, plus R4 of I3 equals to, there is no source, 0. Now this is I3 of R3 plus R4 minus R3 of I2 equals to 0. This is our equation number 2. Finally, the current I from the current source is equal to the difference between the two mesh currents. That is, the current source will consider this as I, then I equals to I1 minus I2. This is our equation number 3. Now by solving these three equations, we'll get loop currents I1, I2, I3. Let us solve this problem. Now, this is the given network is having 8 branches and nodes A, B, C, D, E. So 5 nodes with a reference node including. Then total meshes M is given by branch minus nodes including the reference node plus 1, that is nothing but 4 loops or mesh equations. Or simply by inspecting this, we can say that we have 4 meshes, that is I1, I2, I3 and I4. In this problem, you can observe between B and E there is a current source. Similarly, C and E there is a current source, and A and D there is a current source. So we have 3 current sources here. So we need to apply the supermesh analysis. For that, we need to ignore the current source branches to form a super loop. Then from E, here there is no current source in this branch. Here also there is no current source, and there is also no current source in this. And here also no current source. This is my super mesh or super loop. Let us apply KVL for the super mesh. So first this branch where I1 is opposite direction to I3, so minus I3 of 10 ohms. Then in this it is 1 ohm, so plus I1 only there, minus 10 volts for this branch, and for this branch it's going like this, so 4 I2 minus 20 volts, and for this branch 8 I4 minus 30 volts, and for this branch 20 ohms multiplied by I4 and I3, so I4 is positive minus I3, that equals to 0. Now simplify this, 11 I1 plus 4 I2 minus 30 I3 plus 28 I4 equals to 60. This is our equation number 1. Now we got the equation for super loop, but we need 4 mesh equations as per the formula. The remaining things is the BE branch BE. When you consider, then we'll be having a current that is 5 amps, which is equals to the difference between these two loops, that is I2 minus I1. Now I'm considering I2 as a positive since the I2 loop current which we assumed is in the same direction of the 5 amps current source and I1 is in opposite direction. Now for CE branch there is a current of 10 amps which equals to the difference between these two loops, that is I2 and I4, whereas the current of I2 loop is in the same direction, so I2 minus I4 I am considering. Another current source that is in AD branch which is only connected to I3, so this is 15 amps only connected to I3. So we have 2, 3, 4 mesh equations from which we need to find out the currents I1, I2, I3. From this 4 equals to I2 minus 10 amps and from this I1 equals to I2 minus 5 amps. If you substitute that, you are going to get 11 I2 minus 55. If you substitute I1 value here, then 4 I2 and I3 is minus 30 of I3 is 15 plus 28 I4. I4 in terms of I2, so 28 I2 minus 280 which equals to 60. 43 I2 equals to 60 plus 785 which equals to 845. Then I2 equals to 845 divided by 43, that is equals to 19.65. Now we got I2. Then I1 equals to, if you substitute in this formula, that 19.65 minus 5, that is nothing but 14.65 amps. Now I4 equals to, if you substitute in this, 19.65 minus 10, that is equals to 9.65 amps, and we have the I3.